and we will continue with how to manage the gathered data from the control system, and finally we will talk about the plant security, studying the different security systems. So, during the first chapter, we will talk about the control and telecommunication system.
Sorry, Javier, if you can speak louder. Thank you.
Yes. Do you hear me better?
Yeah,
Fernando?
much better. Thank you. Yeah, it works.
Okay, I'm
much
sorry.
better.
Yeah, I didn't have the microphone properly. Sorry. So, well, I will start, as I have said, with the first chapter, which is the control and telecommunication system. The main reasons to have a monitoring and control system are to invoice the produced energy and to control the energy that is being produced, then to detect the incidents and malfunctions of the plant and each of their elements as soon as possible, because we have to be able to solve them, avoiding losing energy, and then finally to guarantee the availability and the performance ratio of the plant. In order to do this, we have two different concepts that we must know: the monitoring and the remote control. The monitoring is to control the state and evolution of one or various parameters to detect possible malfunctions using specially designed devices. So, while monitoring, we don't modify any device or parameter, while the remote control allows us to modify the state of the equipment and devices of the plant from a remote location. It is important to know the difference between both of these tasks. In this slide, we can see the elements that we can usually find in a grid-connected PV facility. Normally, the main elements to be monitored are the meters and the inverters, but we can also use calibrated cells, temperature sensors, and other devices to monitor different parameters that might be useful for our data management. Anyway, in the next slides, we will study all the parameters to be controlled in the different elements of the PV facility. Usually, we use data loggers to gather all the information. A data logger is a small computer with several inputs and outputs and a solid operating system that only gathers all the information and stores it. About the monitoring system, it is important to be conscious that its features will depend on the capability for each plant to afford its costs. The main requirements for a monitoring system will be the reliability and the robustness. Talking about the reliability, we need stable communications so that we don't lose the link where we are reading the data. Normally, we recommend using wired connections, as wireless connections may produce interference and the data may probably not be able to be read properly. It is also important, as we have said, the robustness of the monitoring system, so that we can gather all the data containing the errors, incidents, and alarms.
Yes, Javier,
So,
excuse
depending
me. It seems that it's still not too loud, so you can improve the voice options. So close to the talk button, you can go to voice options, which is the arrow close to the lock,
yeah,
and then select high volume instead of other options.
okay.
Okay, great. It seems better now. Thank you very much.
Okay, you're welcome, Fernando. Well, I was saying that depending on our own requirements and the plan budget, we can decide between a commercial solution, which is the solution that can be found in the market, or a customized solution. The main advantage for a commercial solution would be that it's an already developed solution, so it might be cheaper. But normally when we have to select a commercial solution, we have to take care that the solution is compatible with the different manufacturers of all the elements in our PV facility, and sometimes that might be quite difficult. So we have to choose a customized solution where we can decide which elements we want to monitor, and it might be more scalable and it can be updated by our software developers once that we install any new device in the plant. During this next chapter, we will study the components and infrastructures in the control system. Here we can see the main elements that are to be monitored in a solar PV facility. As we have said, the main elements to monitor are the inverter and the meter. The parameters to be monitored in the inverter are the instant power, the produced energy, and the CO2 emissions. The main incidences that we might find in the inverter are the electronic failure and the electric failure. This last one means the stop of the whole PV facility, so it's an incidence to be analyzed. Anyway, we will go through these incidences during the next slides. In the meter, we have to control the produced kilowatt hours and the load profile. The only incidence that may happen in the meter is the meter stop, which would also mean the stop of the whole PV facility. So this is why both these elements might be drastically supervised by our monitoring system. Anyway, different elements to be monitored would be the panels and the transformer. In the panels, we can monitor the string current and the irradiance. The string current is quite easy to be monitored with some devices that are available in the market. Here we can find other elements that are also able to be monitored within a PV facility. The most typical ones would be the calibrated cell and the meteo station. With the calibrated cell, we can monitor the radiation from the sun, so we can detect if the panels are producing lower energy than they should produce when there is a higher radiation. With the meteo station, we can detect the wind speed and the temperature. The temperature is important to know if the panels are producing the energy they should be producing. So, as we saw in the last chapter, with the calibrated cell and the meteo and the temperature sensor, we can know more or less how much energy the panels would be producing. If they are producing lower than they should be producing, our technical staff should take care and check all the panels. Also, the wind speed might be really important when sun trackers are being used, as high wind speed may damage the sun trackers. So when high wind speed is detected, the sun trackers have to cover themselves by positioning to a different orientation that the wind may not damage them. Different elements that may be monitored in a solar plant are the current sensors and the protections. With the current sensors, we can monitor the current in the strings of the panels, as we said in the last slide, and the protections must be monitored if we want to install remote control systems, as we might see during the next slides. Here we have the topology of a monitoring system. So we see the different inputs which might be the sensors, the inverter, and the meter. What we have there is the communication port that it's usually used for each of these devices. In the inverter, we normally use the RS232 or 485. And this is also the port which is normally used in the meter. The new inverters support also Ethernet connection. So, the communications allows our system to communicate with all these devices. As we have already said, we can decide between a wired connection or a wireless connection. Normally, we recommend wired connections as it's more reliable. We have also the choice between a logical or a non-logical converter. If we want to use non-logic communications, then we have to use a converter like ones we can find in the market. For example, the most typical one would be called the MOXA, which converts a serial bus to a different types of bus. If not, we can use logic in our communications using what we have described in the previous slides, a data logger. This is, as we have already said, an element that gathers all the information from the different devices and stores it to be easily analyzed from a different computer. Then we have the control room. Here we might have a server and a display. With the server, we have to gather all the data from all the elements. Depending directly from the element if we are using communications without logic, or from the data logger if we are using communications with logic. Then we have to analyze all this data and to generate the alerts that take place depending on the information that we are analyzing. Finally, we need internet communication to send these alarms and to send all this data to be visualized from remotely. Talking about the alarms, we can decide between different types of alarms. Normally, the most effective one is the siren, which may produce a sound that should be heard all over the solar installation. Another different alarm that is more and more used every day is the short message sending, that might be sent to all the staff in the solar plant. Finally, it's important to save also all this information outside the solar facility. So, an internet connection might be needed in order to store all this data in a database over the internet. Here we can find the monitoring system typical routine. Once the data is being gathered and analyzed, we can find that the performance is average or higher than average. So we then will know that the state of the solar PV facility is correct and nothing is to be done. But if the performance is slightly lower than average, then we should analyze all the parameters in the solar plant, especially the ones that are coming from the inverters, and do the actions or modifications in the system to improve these parameters. These modifications can be done remotely or in situ depending on our remote control system, but usually it is necessary to have staff in the PV facility. All the modifications that we have done have to be included in the preventive maintenance in order to be done periodically to improve the plant performance. If the performance is lower than the average, then a malfunction may be happening. Normally, this may generate an alarm from the monitoring system, so that the actions and the modifications on the system can be done urgently and as soon as possible. Every time there is an incident, we have to do a report, and also we have to add all the information to the corrective maintenance order in order to do these tasks periodically to improve the plant's performance. Finally, it is important to have an incidents and parameters log in order to be read once that a new incident happens. In this slide, we have the remote control system basic topology. We can decide between different types of remote control system depending on the performance that we want to get from them. Here we can find a remote control system with only on and off switches for system reclosing. This means that in case of a breakdown of, for example, the tracker control, so that the tracker may stop, this can happen maybe because some wind, because high wind is occurring, then we can decide, once that the wind is lower again, to reclose the switch for the tracker control and reactivate the sun tracking. Another devices that might have this type of reclosing could be the monitoring system and the security system. Here we can find an advanced topology for the remote control system. It is important to know that this kind of remote control systems require larger bandwidth and robustness, and all the elements in the solar PV facility must be prepared to be managed remotely. So, with this kind of system, we can do updates and modification in the orientation of the tracking system. We can do new configurations or new or register new meters or inverters in our monitoring system remotely, or we can also check all the parameters in our security system and even receive all the data and information from the internet. We will see later an example of our solar plant where we have a monitoring system that can be configured remotely, and we also have a security system where we can get video image from the internet. So, talking about the communications in the solar plant, we have to distinguish between two types of communications: the internal communications between all the devices, data loggers, and elements in the solar plant within the PV facility, and the external communications to communicate from our main office. For the internal communications, we have to decide between two different topologies: wireless systems or wired systems. As we have said several times during this presentation, we recommend using wired systems. Among the different types of wired systems, the most typically used are the RS485 and the Ethernet systems. I guess that you all know more or less both of them, but you can find a lot of information about both of them in the internet. Anyway, it is interesting to know that converters can be used to change one signal to a different one. For example, it is really typical to use optical fiber from the control room to the different rooms over the area of the PV facility, and then use a converter to get the data gathered with a RS485 bus and to convert it to the optical fiber bus. Talking about the external communications, also different topologies can be chosen. The most typical one are the basic telephonic network, the ADSL, so that means the internet, the LAN internet, the satellite, or the cell phone internet, talking about the GPRS and the UMTS. It is important to know that the robustness of these links might be critical for our solar PV facility. Here we have a comparison table for the different technologies to be used for communicating the plant remotely. We have more stars in those aspects where the technology is better than the others. So we can see that the technology which gets the best coverage might be the satellite one, but also the cost for this type of technology is the most expensive one, both for installing and for operation. The most recommended technology might be the cell phone technology by UMTS, as the networks are being developed nowadays more and more quickly. Anyway, if we have telephone network coverage in the area of the PV facility, which might be quite odd, then this might be the cheaper way and the most reliable way to communicate with our solar plant. An important point to consider when designing our monitoring system is the remote meter reading. Nowadays, the electrical company is installing in most of the countries in the world the technology that allows to read our meter remotely so that they can avoid having dedicated staff to read the meter locally. This is really useful for the invoicing of the electrical company. Another different advantage of this kind of system is that if the data is well processed, the electrical company might be able to improve the grid performance. So here we can find two different topologies to read the hour meters from the electrical company. One of them might be by a GSM modem installed for each of the meters within our PV facility. But if we have several meters to be read from the electrical company, it might be interesting to install a converter from Ethernet to RS485 so that we can only use one modem and save costs for these communications. It is important to know that in the future PLC communications might be applied. So if we want to do a new PV facility, it is important to get information from the electrical company to know if they are going to apply this type of new communications soon or if it is better to apply GSM communications. The most usual problems that we might find within the communications in a PV facility are using the same system in different facilities, the compatibility for different solutions, and the coverage failure. By using the same system in different facilities, we mean that a system that is working properly within a solar facility might not work in a different one, because the software versions for the different elements are different depending on the year that they are being produced, and also the protocols are different depending on which country we are using the system. For example, here in our experience here in Spain, some of the monitoring system could not be installed because the meters here in Spain use a different protocol than the one which is used all over the world. By the solutions compatibility, we mean that sometimes if we mix different solutions from different manufacturers, that may produce system malfunctions due to transference times and bandwidths of our communications elements. And by the coverage failure, we mean that sometimes our PV facilities might be installed in isolated areas. So these areas normally don't have telephone network, neither cell phone coverage. The only way to communicate with these areas is by satellite. That might be very, very expensive. So,
Sorry, Javier, if you want to make a short break, we can do it now. Sorry, I didn't announce this at the beginning, but we can take probably 3 minutes pause, and we relaunch again if you want to make a break. How do you find it, Javier?
Yeah, I was going to announce the same, Fernando, so thank you very much for
Okay.
your announcement.
Okay, very well. So, okay, Javier is taking a pause now. In the meanwhile, you can you can download the presentation in the link using the link that it's presented here below. You can as well, as you are chatting a lot, you won't probably establish contacts with the other participants of this session. So the best way is probably to connect using a dedicated LinkedIn group. So this is a group dedicated for this webinar program. So you will find a reduced number of people. So it should be easy to connect and to find your counterparts. Finally, if you want to contact Generalia group for any request, either engineering or training or consulting, you can do using the website that is indicated in the link, or you can use as well the email of Luis Recuero, which is indicated there too. Finally, for any request, comment, or anything about the webinar program, you can submit to myself your request using the email address which is indicated just over there. Very well, so as for your comments about sound difficulties, in principle, if your internet connection is good, the sound delivered until now has been quite proper, so the recording will have the same sound quality. In case you experience problems, please, from some hours now, you will have the recording of this presentation available in the same link that is indicated here below. Very well, so now we can resume the presentation. So Javier, the floor is yours again. Thank you very much.
Well, hello everybody again. We will be back to this webinar 3. Now we will study how to manage the gathered data from the control system. We have to know that the main objective of our monitoring system might be to optimize the productivity of our solar PV facility. So, for us, the most important device will be the meter. Why? Because it is the last device in the system. It is the device that meters all the energy that is produced and injected to the grid. So, if we control that we are injecting the maximum energy to the grid, we will have the maximum performance from our solar PV facilities. We need references from different devices in order to know if we are producing what we might be producing. As we have said, the most typical references might be the radiation and the temperature. Other references can be our experience or reference facilities in the same area as ours. Once that we know that the emitter is the most important element to be monitored, we have to know that the inverter can help us to prevent future malfunctions. The emitter doesn't give us any information about the performance of the plant, only the energy that is being produced. But the inverter can give us warnings and messages concerning the state of the different devices in our solar PV facility. We have to make the difference between a sporadic technical failure, which is something to be repaired as soon as possible, and a design failure, which is something that might be redesigned and modified in our solar PV facility. It is important to know that due to an inverter malfunction, the plant could stop completely. The key points to get the best operation of our solar PV facility are detecting the incidents in real time, predict and solve as soon as possible all the incidents and breakdowns. This is where the inverter has a very important task in our solar plant, and this is the main point why the inverter should be monitored. And finally, to warn all the staff in our solar plant. So, in order to do this, we need alarms such as sirens and short messages. We must know that the local plant staff can never be replaced by any software or remote control, and that it is essential to have spare parts and equipment at the PV facility in order to solve all the incidents as fast as possible. Last day we had, for example, some questions about the size of the inverters, and if you remember, in the answer we said that it was an advantage for having smaller inverters might be that it will be easier having spare parts, so that if an incident happens, this inverter can be replaced within less time. In this slide, we have a typical example of a PV monitoring system. This is the monitoring system that we have in our solar plant in Valdecarávanos in Spain. It is a small town in the south of Madrid. All these squares that you can find in green or yellow are the different meters that we have in our solar plant. So those meters which are colored in yellow mean that they are producing a little bit lower, like a 5% lower than the rest of the meters. We use the average of all the meters as a reference in order to know how much energy the panels might be producing. So if we find a yellow meter, we know that we have to modify the state of the sun tracker for that meter. Here we have the control panel for the monitoring system, as it is also a remote control system, and we can interact with our solar plant and modify the states of the sun trackers, and also upload information to the internet in order to save all the gathered data from the meters. And finally, we have an area where where the software notifies all the incidents and alarms that may happen in our solar PV facility. This software is a customized software that works over a Windows-based system. Now we are going to talk about the remote control system. The main reasons to install this kind of systems is because of the legal requirement, and also for us the main reason might be to save costs. With this kind of system, we don't need to go to the malfunctioning element to repair it. So we can save the time. We can save time because the plant will be producing again faster than if we didn't have the remote control system. And we can also save personnel because with less staff we can do the same work as it can be done remotely. The main devices that we have that can be remotely controlled are the inverters and the sun trackers and the protections. Some other elements that can be controlled remotely but that may not increase the benefits from our solar PV facility are the monitoring system and the security system. It is important to notice that the meters can never be controlled remotely. PV facility, the main elements to maintain are the inverter, the sun tracker, and the panels. The inverter is the main element to be maintained if there is no solar tracker, and in the next slides we will see which incidents may happen in an inverter. The sun tracker has only to be maintained in case that we are using them obviously in our PV facility. We will also see which are the main incidents that may happen in our sun tracker if we are using them. And finally, the panels they don't need so much maintenance, only some cleaning up periodically that it could be done once every 3 years, depending on the area, as we said during our first webinar, and the replacement if one of the panels requires to be replaced. Anyway, it is important to make the difference between two types of maintenance tasks. The corrective tasks, which are used once that an incident has already happened and in order to solve these incidents as soon as possible, and the preventive task that will be done periodically in order to prevent a possible incident. If you remember, during the slide that we talked about the monitoring system and the routine that to be done from the information that we gathered from the monitoring system, we defined that if we had low performance and we needed some task in order to improve this performance, these tasks might be added to the preventive maintenance tasks so that they can be done periodically. In an inverter, the main failures can be classified according to its seriousness or according to its origin. According to its seriousness, we can distinguish between two types of failures: the warnings and the alarms. We only have to consider the alarms because they are important to be minimized, as because of an alarm, if we don't interact very fast, the plant could be completely stopped. The warnings are not so important, as the inverter will be the whole time sending us warnings with the different parameters of the different elements of the solar plant. It is important to know that from an inverter we can get data from internal, so that means data that comes from the inverter, and also in the new inverters we can get data external from this inverter. This means data from our solar plant. This is very important to be used in our monitoring system because we can obtain data of the DC side, so we can get the energy that is being produced by the different strings of panels, and also we can get data from the AC side, so from the inverter, from all the side that goes from the inverter to the grid. most typical incidences that we can find in an inverter are the isolation failure, which is a failure from the plant, the low DC voltage, which is also an external failure in the modules array, the maximum point tracking system, which can be both an external failure if we have a wrong configuration in the panels that may produce a deviation from the maximum power point tracking, or an internal failure in the configuration or firmware of our inverter. This is the most important failure that we can find in an inverter, because as we said during the last webinars, it is really important to get the maximum energy from our solar plant by improving the performance of the maximum power point tracking system. The last incidence that it is important to consider is the frequency out of range alarm, which is an external failure that is produced from the inverter to the grid. We will end this chapter talking about the sun tracking maintenance. As we have said all over the presentation, it is important to know that this type of PV facilities, this type of maintenance, are only to be done within PV facilities that include sun tracking systems. The most typical issue that we might find in a sun tracking system is the orientation or position failure. This can be produced because the sun tracker is not synchronized with the position of the sun. So, it is important to have a system that checks periodically that the position of the sun tracker is synchronized with the position of the sun. In this type of facilities, it is really important to have a remotely controlled system so that we can modify the position of one of the sun trackers if it is necessary. Another important maintenance task will be in case of wind, because these kind of elements usually change their position in order to protect if high wind is happening. We have to detect that the system is protected if we are detecting high wind, but we also have to take in account that the system might return to its normal position once that the wind has gone lower. Finally, another issues to be detected are the overvoltage and the limiting movement sensor. The limiting movement sensor is a sensor that avoids our sun tracker to overpass a position where the sun will not be detected. We will end this webinar session with the plant security and the different security systems to be installed in our solar plant. It is important to know that there is not a perfect solution in order to completely guarantee the security of our solar plant. But from our experience, we know that the best solution will be combining both local staff and remote security systems. The main reasons to install a security system in our solar PV facility is that our PV facility contains really expensive elements, and there are many thefts that may be trying to rob all these elements. If the elements are being robbed, then we might have to replace all these elements with all the costs that it implies, but we also have production losses that might be avoided. So, as our systems are being installed normally in isolated areas that are with long unattended periods, it is important to install a very good security system. Here we have a list of the most typical security systems to be found in the market. First of them to be considered is the local staff. Then we have the video surveillance system, the perimeter sensors, the panel Cwin, the string controllers, and the infrared and microwave movement detectors. During the next slides, we will study all of these systems. Here we have an scheme of the solar plant security system. We can find in this picture all the devices that might be installed to increase the security of our solar PV facility. We will not explain all this picture as we will go through the different devices during the next slides. So let's study all the different security systems that we can find in the market. As we have already said, the most important security system, if we can call it the security system in our point of view, is the local staff, because it is a very dissuasive solution if thefts are trying to steal our solar plant elements. For sure, we also might find some drawbacks in this kind of solution. The most important one is the expensive costs in the long term that may reduce the plant profitability. Anyway, we can decide between two different options: whether getting our own employees or outsourcing the security staff from one of the companies that provide this kind of services. The video surveillance system is a system that is being installed more and more lately because the price is being reduced and the technology has improved a lot during the last years. We have to decide between two types of system: the closed TV circuit or the IP system. The closed TV circuit is an old technology that requires a dedicated transmission bus and that might be more expensive than an IP-based solution. So we recommend using IP-based solutions because we can find good quality and good transmission, and we will need less wiring, so we can reduce the price of this type of systems. It is important, if we want to install one of these systems, to know what is an encoder and decoder of digital video. Normally we can find integrated devices as the one in the picture that work as both the encoder and decoder of the video signal, and that also allow us to introduce alarms and relays in order to do the remote control of our solar PV facility. Normally, these kind of elements also integrate a great storage capacity. If we want to get to better systems, we might need to install different devices in order to do the different tasks. But we recommend using commercial solutions that integrate all these devices within the same device, as they work really fine and they are not so expensive nowadays. It is also important to know that we can get video analyzers that, using specialized software, can detect movements within the radius of our solar plant. The only disadvantage for this kind of system is that they are very expensive, so we have to consider if it's profitable for our solar PV facility, depending on its size, whether to install this system or not. Anyway, non-depending on which kind of technology we are selecting, we need to install video cameras, and it is important to know that nowadays these video cameras have great optical zooms that can get to 60 times the zoom capacity, so we can get several kilometers, and that also have infrared technology in order to record also during the night within a range of 1.5 kilometers. It is important to know that these specifications are the ones that we have obtained from the manufacturers, but from our experience, the distance that we can get for the optical distance will be up to 1 or 2 kilometers, and during the night we shouldn't expect getting more than 150 meters. We can find several anti-intrusion systems in the market, but the most used ones are the perimeter sensor system and the presence sensor. In this slide, we are going to study the perimeter sensor system. Its main task is activating an alarm if a movement is detected in the radius of our solar PV facility. We can choose between installing these kind of sensors in the wall of our PV facility, which might be more vulnerable, or buried underground. This solution is better, but it will also be more expensive. Anyway, the best solution in the market will be using optical fiber systems, which are passive systems that are not affected by storms or electrical systems, and that can also do a false alarm discrimination or detect if our fiber is cut. Also, this kind of system have great temperature range. You have a small picture at the lowest right side of this slide explaining how this system should be installed. Here we can find a presence sensor, which is the kind of device that you can see in this picture. It detects both thermal energy variations and movements because it integrates infrared and microwave technologies. These kind of systems are quite different to be configured, as they can be configured for both detecting the thermal energy variations and movements and being only activated if both of them are being detected. So problems may occur if we have if there are fogs or during the night, and also we can configure them for only for sending an alarm if they detect just one of the two variations that we have seen. The only problem that we might find if we select this type of configuration is that they may produce a lot of false alarms. In our experience, these elements are quite dissuasive, but in fact they are quite difficult to be configured, and finally they produce a lot of false alarms. Another security system would be the panel Cwin. This system consists on a wire that is attached to every panel in our solar PV facility. Normally, this kind of wire is also produced with an optical fiber technology. This system sends an alarm if the fiber is cut. There are also other types of wire that work with electrical current, but some of the thieves already know this kind of systems and can introduce sabotage to the solar plant in order to rob the panels even these kind of systems are being installed. So we recommend, if we want to use this panel Cwin system, we recommend using optical fiber instead of conductive wire systems. Here in this slide we can find a picture of a string controller. With this type of device, we can control during the day the power that is being produced in the panels, so we can use it also for the monitoring system, and it has an added value protecting the plant with integrated fuses. And during the night, it detects if an electrical cable has been cut or broken. This kind of system has been optimized to detect this kind of incidents even if there is no voltage or current in our PV facility during the night. It is quite a new system, and you should check with the manufacturer the price for this kind of solution. Here we can find the alarm management in our solar PV facility. As we have already said, it is really important to install a local alarm that sounds if we get an incident from the monitoring system or an incident from our security system. For the monitoring system, it is important to install this kind of siren or speakers so that the staff of our solar plant may notice if an incident is happening. But for the security system, it is a very dissuasive measure to install lighting and sirens in the PV facility. Another different aspect that might be considered is communicating our security system with the local authorities so that if anybody enters our PV facility, a message is sent to the authorities, to the local authorities, in order to come to our solar plant. We have to consider the plant visibility and the distance to the security entity. So, when selecting the security system, we have two options. The dissuasive option to avoid our solar plant to be stolen, or notifying the authorities in order to catch the thefts. Finally, we will end this webinar explaining a new type of system that is being installed nowadays, which is called the virtual patrols. It consists on outsourcing the security system, contracting a surveillance agency that may install video cameras all over the solar facility, and with authority that is close to our PV facility, they control virtually our PV facility, and if something happens, they notify the alert to the authorities, and normally they also can go to the PV facility in order to dissuade the thefts. Finally, we have introduced a paragraph considering the security for rooftop facilities. Normally, these kind of facilities are also located in isolated areas and which are difficult to access. So, it is recommended to apply one of the security systems that we have described in this presentation. But from our experience, it is important and very recommended for both cases, in rooftops and in ground facilities, to get an all-risk insurance so that if anything happens, we can have an insurance for both the elements in the PV facility and the production losses that are being produced due to the theft or to the maintenance tasks. So, with this slide, we are finishing with this presentation. Thank you all for attending to this webinar session 3, talking about the plant operation, and we will continue with all the PV facility tasks during the next 3 sessions of this webinar course. Thank you very much.
Okay, thank you, Javier. Maybe we have time for 5-10 minutes of questions. So let me resize the pods, and we will go for this Q&A session. So Javier and Luis, I let you visualize the questions. I let you consider the ones, well, the most relevant ones, and you will be selecting and managing your own. In the meanwhile, I'm modifying the pods so Q&A can now start. When you select a question, then you should use the button Answer Everyone to be sent to the Q&A pod visible in the window. Thank you very much. Submit your questions, and in the meanwhile, Javier, I let you make your selection, and please start in sending question and providing the answer. Thank you very much.
Well, I have selected one of the questions which might be interesting. There is a person who asks if the solar panels can be monitored individually, so it should be easy to see if a panel degrades. This could be technically done, but in fact it is not recommended because it is not economically profitable. Normally, the kind of monitoring systems to be installed are quite expensive, and we try to recollect all the data from our PV facility. New techniques that are being developed, like the one that we saw in one of the last slides in our presentation, are the string controller devices. With this kind of device, we can monitor one of the strings of panels, that means one of the rows of the panels, so that we can know if the energy produced row by row it's the energy that should be produced for a normal performance of our solar PV facility. Anyway, if the panels are not reducing their performance drastically, we can consider that from a typical tolerance of a 3%, it is not important to get less performance from one of the panels. If we find that the production from a row or from a whole sun tracker or a whole panel area is lower than it might be, we can do one of the practices that we saw during webinar 2, like for example the thermal study of the panels in the area that we are detecting that is producing low than it should be doing.
you very much for this answer. Again, I let you select the next question. We will be proceeding for additional 5 minutes if you agree, Javier. Thank you very much.
Yeah. Okay. Well, uh, I'm sorry for the time that we were checking all the questions because a lot of questions have been sent, and we are trying to select one of the ones that we find more interesting. So we have selected now a question which is quite interesting for the spare modules that we suggest to order for a solar plant of 5 megawatts. Here we have to say that the solar module is a device that it's quite static, and normally it's not we do not detect many malfunctions or defects in this type of devices. So we will recommend having not too many spare parts. We will recommend having just like from a 2 to a 4%, sorry, lower than a 1% of the energy that is being installed. This is also because we have to consider that the price of the modules will be cheaper in the future. So if incident happens within next 10 years, for example, the price of the modules that we might find during the next 10 years might be cheaper than the price that we can find today. From NATO, who asks what monitoring system is needed for a rooftop PV grid connected system. Here we can find a lot of commercial solutions in the market where our facility might be monitored remotely. Sometimes it is important to remotely monitor this type of installations, as the company that it's installing the system is not the same as the company that it's in the company that works under the roof where the PV facility is installed. So normally we can find monitoring systems that use the cell phone network to communicate with this type of rooftop facilities, and we can get the data from them. Usually we can find solutions from easy modems so that we can just read the meter and the data of the product of the energy produced, to solutions of data loggers that send us emails and short messages in case that an incident is happening in the inverter. We can find in the market several companies that are specialized in this type of solutions, with a range of prices between 150 euros to 1000 euros for the monitoring of one of the solar roofs.
Well, thank you, Javier, for this answer. So we will proceed to the last question. Thank you.
We have chosen another question, that is, what is the required time response of the remote control system? For both the remote control system and the monitoring system, our objective, our aim, might be getting our response and our signals in real time. This can be done technically with the solutions that we can find nowadays in the market. So, the answer to this question might be in real time. Sometimes we can integrate the monitoring system with the remote control system in order to automatically modify one of the behaviors of an element in the solar plant. But for example, if we have detected that the position of a sun tracker is not synchronized with the position of the sun, because we are detecting that the energy produced in that sun tracker is lower than the energy that is being produced in the in the in the rest of the sun trackers in the PV facility. It is important to be able to in real time modify the data for that sun tracker and modify the position. For example, if you get back, Fernando, I don't know if it's worth it to get back to the slide of our solar PV facility where we could see all the different sun trackers in our PV facility with the energy that is being produced in each of them. I have explained that some of them are colored in yellow, and that means that they are producing less than the rest of the sun trackers in the PV facility. As you can see, we can see that information in real time, and we can connect with the sun tracker in each of that positions and be able to modify to get the position of that sun tracker and check if it's synchronized with the sun or if it is not, modified in real time.
Okay, thank you very much, Javier. So now we adjourn the session here. Thank you very much for your participation. The rest of questions will be treated in a few days and we will provide a written answer. So check the link and it will be published there in some days. So now I let you chat further if you wish. So let me chat window. And for any additional networking activity, you can use the link provided here below. It's a LinkedIn dedicated group. So you can go there and establish your contacts and develop your activity. Very well, thank you very much. See you next week, Tuesday, for the 4th session, and have a nice week. Javier, if you want to say goodbye, I give you the floor. Thank you very much.
Well, thank you everybody for attending to this webinar session 3. As Fernando said, we will try to answer the most interesting questions by email and to post them into the forum so that everybody can read them. And we will continue with these webinars next Thursday, as Fernando said. So thank you very much to everybody, and see you in the next